3.3 million years ago, one of your ancestors genuinely caught this from a gorilla. The transmission likely happened when an early hominid slept in an abandoned gorilla nest or butchered one for food. What they caught was Pthirus pubis, the parasite responsible for crabs. This reveals a unique biological anomaly. Humans are the only great apes that carry two structurally distinct species of sucking lice at the same time. Because lice are soft-bodied and fragile, they never survive in the fossil record. This creates a massive hurdle for researchers. How do you pinpoint where a second louse came from when the physical evidence vanished millions of years ago? Solving this mystery shows that our living bodies carry physical records of our ancestors' daily habits, preserving details that no ancient skeleton ever could. In 2007, David Reed and his team at the University of Florida set out to find the answer. They compared the genetics of lice collected from modern humans with samples taken from gorillas in Ugandan wildlife sanctuaries. The team relied on the concept of the molecular clock. A parasite's DNA accumulates mutations at a roughly predictable, steady rate over time. By measuring the genetic differences between human pubic lice and gorilla lice, the researchers used that mutation rate to calculate the exact window when the two lineages diverged. This molecular clock converted evolutionary biology from speculation into testable numerical data. 13 million years ago, a shared ancestor of all modern great apes carried two distinct louse lineages, one adapted for fine hair and one for coarse hair. When gorilla ancestors diverged from the line leading to humans and chimpanzees around 7 million years ago, both lineages initially kept both types of lice. Then, two independent extinctions occurred. Gorillas lost their fine hair lice, while human and chimp ancestors lost their coarse hair pubic-type lice. For millions of years following these extinctions, each primate lineage hosted a single species of louse. This extinction on the human branch left an unoccupied biological niche, an empty habitat on our ancestors' bodies waiting for a new occupant. Between 3.3 and 3.5 million years ago, a Pthirus louse jumped from a gorilla host directly onto an early human ancestor. This transmission matches the period when early humans were losing their dense body hair. As the body thinned out, the coarse hair of the groin and eyelashes remained the only habitat suitable for the gorilla louse's specialized claws. David Reed clarified that this was not a sexual transmission. It resulted from mundane environmental overlap, such as hominids sleeping in abandoned gorilla nests. This crossover provides a verifiable record of early human survival behaviors, diets, and foraging habits. Under a microscope, the anatomy of Pthirus pubis explains its habitat. Its short, broad body and prominent claws are specifically evolved to grip coarse, widely spaced hair. Infestation causes intense allergic itching and the appearance of nits cemented to hair shafts. Patients may also develop maculae ceruleae, bluish spots caused by the louse's anticoagulant saliva. Because the louse moves slowly and cannot jump, it requires close, prolonged physical contact to spread. For this reason, finding pubic lice in a prepubescent child is a significant clinical warning sign that prompts an evaluation for sexual abuse. While treatment is standard, involving topical insecticides and laundering bedding, the louse's biological inability to spread casually makes its presence a major medical indicator. In recent decades, epidemiological studies show a measurable decline in pubic lice prevalence, which now affects roughly 2. This decline is linked to popular pubic hair grooming practices. Shaving and waxing are deleting the habitat this insect depended on for 3.3 million years. Parasite DNA has become an essential tool in evolutionary biology, uncovering cross-species interactions that the fossil record could never preserve. A shared ancestor 13 million years ago, a gorilla's nest 3.3 million years ago, a dermatology clinic today. The DNA remembers all of it. January Science tells the story behind the science, one disease at a time.